and go over these questions. So this is just relating back again what we had learned about fundamental counting principle. I'm going to write it up. Do you understand? Stop, both of you. With the fundamental counting principle, you just take the number of possible outcomes of each specific event or activity and multiply them together. So for here, Lisa has 12 shirts, 9 pairs of jeans, and 6 pairs of shoes that she can wear. And she can wear them in different combinations to create an outfit. So we want to know how many different outfit combinations can she create. Who can tell me how many combinations of outfits? Rowena? 648. So again, we have 12 shirts. So we can take the 12. We've got 9 pairs of jeans. So we have our 9. And then we've got our 6 pairs of shoes. So we can take that 6. And we're going to take each of those values and just multiply them together. So 12 times 9 times the 6 is going to give us 648. So there's 648 different outfit combinations that she could create with just that amount of clothes. Okay, for problem number 2, Josh is going to spin this following spinner, and he's going to roll a die. We want to know how many outcomes, how many total outcomes are there from spinning the spinner and rolling the die simultaneously. How many outcomes are there? Somebody besides Rowena. Come on, guys. This is very, very easy. It's just multiplication. Oh, Josh. 48. Okay, we have 8 outcomes. The spinner, our spinner has 8 different outcomes, right? You can land on pink, blue, orange, purple, green, yellow, black, or white. There are 8 total outcomes for the spinner. And then a die, remember a die has 6 sides to it. So you're just going to take the 8 and multiply it by the 6, and you're going to have 48 total outcomes. 48 different outcomes that it could land on. So you could have a pink 1, pink 2, pink 3, pink 4, pink 5, pink 6, and so on and so forth for all the colors. Okay? Number 3, problem number 3, Kim flips a coin 3 times. We want to know how many possible outcomes are there going to be from flipping 3 separate coins, or flipping a coin 3 separate times. How many? Not 6. Mary? 8. Okay, so think about it. The first time, the first flip has 2 possible outcomes that we could land on. The second flip also has 2 possible outcomes that we could land on. And then the third time that we flip the coin, it has 2 possible outcomes that we could land on. So we're multiplying 2 times 2 times 2, and that's going to give us 8. So there's 8 different possible outcomes that a coin could land on. 2 times 2 is 4. 4 times 2 is 8. Okay? All right. So taking the same concept, we can go ahead and use that with compound probability, where we have 2 activities or 2 separate experiments that we're going to piece together and find the probability that both experiments are going to happen, or both events that we're looking for are going to happen simultaneously. Let's take a look at a couple of practice problems for that. So let's say for the following, I'm going to go ahead and have a spinner, and the spinner is labeled 3, 6, 12, and 18. 3, 6, 12, and 18. That's the spinner. And then I'm going to have different cards, and the cards are going to have letters on them. So I'll have A, X, T, U, and W. Okay? So given the following, we're going to go ahead and answer some probability questions based off of it. I want the probability that I'm going to spin an even number, and I'm going to choose a vowel. I want to spin an even number, and I want to choose a vowel. Now, previously, we might have made a tree diagram and said, okay, well, we've got 3, 6, 18, and 12, and then I'm going to have A, X, T, U, W branching off from each of these so that I can make my sample space of 3A, 3X, 3T, 3U, 3W, and then 6A, 6X, and C. It just gets too much, right? It's long, takes a long time. There's no need to have to do that. If you know what your possible outcomes are for each of them, you can find the probability individually and then multiply them just like we did with the fundamental counting principle. So I can say, okay, I'm going to focus first on the probability that an even is going to happen. So looking at my spinner, how many numbers up here are even numbers? 3 of them, right? 6, 12, and 18. 6, 12, and 18 are my even numbers. 6, 12, and 18 are my even numbers. That's 3 numbers out of how many total numbers? 4. So the probability that I'm going to land on an even number is 3 out of 4. Okay, then I'm going to separate the vowels. I'm going to separate that as a different probability. I want the probability that I'm going to choose a vowel. So what letters up here are my vowels? A and the U, right? A and U are my vowels. How many letters is that? 2 out of how many? How many letters? 5. So we have 2 out of 5. So we've got 3 over 4 and 2 over 5. I can just multiply them. I'm just going to go ahead and multiply them. And guys, use your calculator because your calculator will simplify it for you. If you take your calculator and you type in your fraction button, put 3 over 4, multiply. Don't forget to get out of your fraction when you multiply. Hit your fraction button again, 2 over 5. Get out of the fraction button. Hit enter. It's going to tell you your answer in simplest form. That's 3 over 10. So this comes out to 3/10. If we would have multiplied straight across, we would have just gotten 6 over 20, which would have had to be simplified to 3 over 10. Okay? So just like fundamental counting principle, if you find the probability of each event separately and then multiply those probabilities, you'll have the probability of the event happening simultaneously. Okay, let's do another one. I want the probability that I'm going to land on a number that is divisible by 4. Oops, sorry. And then a probability of an X or a W. An X or a W. So I want the probability that I'm going to get a number that is divisible by 4, and then I'm going to pull an X or a W. Okay, so we're going to, again, separate those events. We're going to separate them. We're going to focus first on the divisibility by 4. So the probability that I'm going to get a number that I can divide by 4. Well, let's take a look at them. Can I divide 3 by 4? No. Can I divide 6 by 4? No. Can I divide 12 by 4? Yes. Okay, so 12 works. All right, can I divide 18 by 4? No. So the only one that works is the 12. That's one number out of how many? 4. So the probability that I'm going to choose a number that's divisible by 4 is 1 over 4. Okay, now let's look at this one separately. I want the probability that I'm going to choose an X or a W. How many X's are up here? 1. How many W's? So how many choices? 2. There are 2 of them out of how much? 5. 2 out of 5. Now what do? Multiply. So we're going to multiply 1 over 4 times 2 over 5. And when we do that, we're going to get 1/10. We'd get 2 over 20, but 2 over 20 simplifies to 1 over 10. Okay, let's try another one. Let's go ahead and do the probability that we're going to have a number greater than 10 and that we're going to choose a consonant. I want a number greater than 10 and a consonant. I'm going to let you guys do this one on your own. A number greater than 10 and a consonant. Okay, so let's go ahead and take a look here. So the probability that we're going to get a number that is greater than 10, and then a probability that we're going to get a consonant. Who can raise their hand and tell me what probability are we going to get if it's a probability that's greater than 10 and pulling out a consonant? What did you get, Eileen? 3 over 25? Anybody get anything different? Yulia? 3/10? Anybody get anything different? No? Okay, so let's check and see which one. So probability that we're going to get a number that is greater than 10. The probability of getting a number that is greater than 10. So is 3 greater than 10? No. What about 6? 12? Yes. And 18? Yes. So we've got two numbers that are greater than 10 out of how many numbers again? 4 numbers. We have 2 numbers that are greater than 10 out of 4 numbers. That's the probability that we're going to get a number that is greater than 10. The probability of getting a number greater than 10 is 2 out of 4. Okay? Now, the probability that we're going to pull out a consonant. Remember, a consonant is a number that is, a letter that is not a vowel. So which letters up here are not vowels? X, T, and W. Very good. So that's 3 of them. 1, 2, 3 out of 5. So we have 3 out of 5. So then we just multiply. And when we multiply, we're going to get 3 out of 10. Okay, so when it simplifies, it will become 3 over 10. Okay? All right, let's move on to a different activity now, a different one. So not using that spinner, not using those letters. Let's go ahead and say that we've got a coin and a die. A coin and a die. So I want the probability that the coin is going to land on tails and that the die is going to land on a number that is greater than or equal to 5. Greater than or equal to 5. Go ahead and find the probability of landing on tails for a coin and rolling a number that is greater than or equal to 5 for a die. All right, who can tell me what is the probability for landing on tails and rolling a number greater than or equal to 5? Allison? Not 1/12. Brianna? 1/6. 1/6. So let's take a look. All right, the probability of flipping a coin and landing on tails. So if we flip the coin and land on tails, how many tails are on a coin, guys? 1 out of how many total outcomes on a coin? 2. So the probability of flipping a coin and landing on tails is 1 out of 2. Okay, now we're going to go ahead and roll the die. So if we roll a die, and I want a number that is greater than or equal to 5. Greater or equal to 5. That means the number 5 and the number 6 are both possibilities. That's 2 numbers out of 6. That's 2 numbers out of 6. That greater than or equal to means it's going to include the number 5. So there's 2 possibilities out of the 6 total on the die. Then we'll just go ahead and multiply them. When we multiply them, we're going to get 1 over 6. So 2/12 or 1/6 in simplest form. Raise your hand if you need a couple more examples. Okay, like maybe one example? Just like one more? Okay, so let's go ahead. I'm going to do one more maybe off to the side so that way we don't have to waste another sheet of paper. Let's do one more example off to the side. Let's say that we've got, we've got 4 red marbles, 4 red, 3 blue, oops, yep, 4 red, 3 blue, 2 green, and 1 yellow. Okay, 4 red, 3 blue, 2 green, 1 yellow for marbles. Sorry, that's kind of a messed up writing right there, but that says 3 blue. So that's marbles. And then I'm going to have six cookies and 3 cakes. 6 cookies, 3 cakes. Okay? So here we're talking about marbles. Here we're talking about food items. So I want the probability that for marbles, stop. I want the probability that for marbles, I'm going to choose a blue. And that for food, I'm going to choose a cookie. Okay? I want the probability that I'm going to choose a blue marble and a cookie for my food. Go ahead and do that one on your own. Okay, so we're separating these out. We're going to find the probability of each one individually. So I want the probability that for my marbles, I'm going to choose a blue marble. So Mario, how many blue marbles are there? 3 out of how many total marbles? Count up all the marbles. How many marbles are there? 10. So it's 3 out of 10, right? 4 plus 3 plus 2 plus 1, that gives us 10. So the probability that we're going to choose a blue marble is 3 over 10. Then for the food items, we're going to focus on picking out a cookie. So Mario, how many cookies are there? 6. Out of how many total food items are there? 9. So we have 6 over 9 for the probability of a cookie. Now all we have to do is what? What are we going to do? Multiply. We're just going to multiply those together. So in your calculator, you're going to type 3 over 10 times 6 over 9. And that's going to give us 1/5. 1 over 5. 1 over 5 is going to be our answer for that one. Okay. What you're going to do right now is you're going to get your computers. And you've got 2 IXLs that you're going to be working on. 2 IXLs. You must get a 70. Hold on. Listen closely. You must get a 70 for the one that's doing compound probability. You must get a 100 on the one that is finding the total number of outcomes. So I'm going to have those IXLs linked separately so that you know which one needs a 100 and which one needs a 70.